Good morning. I hope everything is well with you guys. We're going to continue to work on arithmetic sequences and series this morning. We're going to have one video on some slightly more advanced arithmetic sequence problems, and then one on finding sums of arithmetic series. Okay? Remember, an arithmetic sequence is a sequence that looks like this. And I'll just keeps going like that. If there's a common difference, you see if we subtract each of the neighboring numbers, 7 minus 3, that's 4, 11 minus 7, that's 4, 15 minus 11, that's 4. Since we're always adding 4 each time, we can see that that's kind of how an arithmetic sequence works, right? So in terms of this sequence here, we can see that our a sub 1 was equal to 3. A sub 1, that's the first term in the sequence. And then for this sequence here, d was equal to 4, right? Now, what we did from then was we said, okay, we can construct a formula that would generate any term in this sequence. Those are the only two numbers we need. Okay, and our general formula, remember, looked like this. A sub n, a sub 1 plus n minus 1 times d, where a sub n is just any given term in the sequence that you might be interested in, like the 50th term or the 95th term or whatever. Okay, but always starting with 1 being the first term. A sub 1 the first term, n is the position number, so that would be, so if the number was supposed to be the 50th number in the sequence, n here would be 50, right? If this was supposed to refer to the 13th number in the sequence, then that would be 13 there. And d is the common difference, right, between them. So now for this sequence here, a sub 1 was 3, d was 4, so we just plunk the numbers in. That's 4, and then n minus 1 times, oopsie, well that was silly. The first term was 3, wasn't it? So that should of course be 3. A sub 1 is 4. Okay, now we just simplify that. 3 plus 4n minus 4, right? And then we combine the like terms, the 4, the 3, and the minus 4, and we end up with 4n minus 1. And so that is the general formula for that sequence, right? And I think that's what we did last time, right? Now let me give you another one here. How about you do this one? Negative 1, 5, 11, 17, dot, 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 right? And, yeah, so you're going to go ahead, would you please, like we did here, figure out what a sub 1 are, and what d is, and then what the general formula for the sequence is there, okay? So put your video on pause and try that right now. Okay, and you're back. Well, we know that the formula has to look like this. We can look here, and if it's an arithmetic sequence, then there is a common difference, right? So let's see what they are. 5 minus negative 1. 5 minus negative 1, that's 6. 11 minus 5 is 6. 17 minus 11 is 6. So, yeah, that's an arithmetic sequence, all right? Okay, if it wasn't, if those differences were not the same, right, that would mean that there's not a common difference that we're adding, and which would mean that it's not an arithmetic sequence, and so we wouldn't be able to finish the problem, right? So here, I don't know why I put d was 4. Yikes. D obviously is 6. Hope didn't throw you off too much. And A is negative 1. A sub 1 is negative 1. So A sub n is going to be negative 1 plus n minus 1 times 6. Negative 1 plus 6n minus 6, right? So now we combine, that's A sub n is equal to 6n plus, or actually 6n minus 5, right? Because the negative 1, yikes, minus 7. 6n minus 7. So A sub n, 6n minus 7. Okay, so that's what we should get for that. Okay, now, if you see that, you might look at that and go, oh, Mr. Waters, that's like a linear equation, where normally instead of A sub n and n, we'd have y and x, right? Well, if you've noticed that, that's good. That's pretty smart, because in fact, for an arithmetic sequence, the formula that generates the nth term in an arithmetic sequence is always going to be a linear equation like that one there when we finish simplifying it. Okay? All right. So. Now, the new thing for today is we're going to try out a couple different kinds of problems. Okay? Let's put that aside over here. Okay, so one problem they're going to ask you is simply this. They're going to want you to insert, here's an example here, insert 3 arithmetic means between two numbers, just any two numbers, actually, between 8 and 16, right? Now, an arithmetic mean, FYI, is the general math term for what we think of as just an average. So, for example, if I had 3 numbers and I wanted to find the arithmetic mean, if I had 3 numbers, n1, n2, and n3, and I wanted to know the average of them, the arithmetic mean, I would add the numbers together and divide by 3, right? But in the context of arithmetic sequences, what they mean by arithmetic means, they want you to think of this as an arithmetic sequence, and they want you to add 3 numbers between them such that those numbers with 8 and 16 would make an arithmetic sequence. So it would look like this: 8, 16, like that. So these are 3 numbers that by arithmetic means they want you to insert 3 numbers between them such that these numbers make an arithmetic sequence, right? So that means, right, that I'll write it up here, we're going to be adding. So how do we do that? Well, up here, we're going to think that each time we're going to be adding a number, right? Some common number. So if we knew what that common difference was, so we'd add 8 plus that common d would give us this one. Then that number plus that common d would give us this one. Then this number plus that common d would give us that number, right? So how do we calculate that? How do we figure out what that d would be? Because once we know what the d is, then we can just go ahead and add the numbers in. Well, here's how you think about it. Or at least one way to think about it. Is we see here that if we're putting 3 numbers in between, can you see that, and actually I should have added another d up here, we're actually adding a d 4 times. 8 plus d would give you this, that number plus d would give you that, this number plus d would give you that, this number plus d, whatever it is, would give us 16. So if we want 3 numbers in between, we want to have, we're going to be adding d 4 times. So what I'm going to do is, I'm going to subtract the total difference between the 2 numbers. 16 minus 8 is equal to 8, right? And we've got to span this number, that gap, with four additions. So I'm going to divide that by 4, and we get 2. So that means in order to get from 8 to 16 and have 3 numbers in between, we've got to add 2 4 times. Well, let's see if that really works. Well, 8 plus 2 will give us 10. 10 plus 2 will give us 12. 12 plus 2 will give us 14. And then 14 plus 2 will give us 16. Okay? So we're done. Those are the 3 numbers right there. Those are the 3 arithmetic means your book is calling them. Okay? And the reason why is that 2 is they call it the means because 2 is the average difference between them. Okay? All right, so that's how that works. Okay, inserting 3 arithmetic means. So technically I could just give you, and I'll do that, I'll give you 2 numbers, right? And I'll say put 4 or 2 or 3 or 5 geometric mean or arithmetic means between them, and we'll follow this. So let's try another one here. How about insert. So this is going to be example 1 for this kind of problem. Example 2, insert 2 arithmetic means between 5 and 17. Now, what does that mean? That means we're going to think of 5 and 17 as being terms in an arithmetic sequence where there are now going to be 2 numbers between them. Now, I don't know what's going to happen on this one, but these are not necessarily going to come out to be even numbers, but they will be evenly spaced apart, okay, with the space between them, the D. So we notice here, oh, look, can you see we're adding, if we're inserting 2 numbers, we're going to add D 3 times. So that means that if I'm going to add 3 arithmetic sequences, I'm going to add 4 times. If I'm adding 2 arithmetic means, if I'm adding 2 numbers between them, I'm going to add 3 times. So what I'm going to do here is, I'm going to take the final number, 17, minus 5, right? That's a total of 12 units, or 12 numbers that we have to span, adding 3 times. Divide by 3 there. Okay? That's equal to, oh look, 4. Right? That means if I'm going to get from 5 to 17 and stick 2 numbers between them that are evenly spaced, that means I've got to add 4 3 times. Let's see if that works. 5 plus 4 would be 9. 9 plus 4 would be 13. Oh yeah, 13 plus 4, 17. There we are. We added 4 each time. And what we get, in effect, there you see is an arithmetic sequence. It begins with 5 and has a D of a common difference of 4. Right? So that's how that goes. Now, why don't you try one? Okay. So this is going to be a U try now. So this will be example 3. And so insert 3 arithmetic means between 10 and 25. Let's see what we get. You try that out. Okay? Insert 3 arithmetic means between 10 and 25. Okay, and you're back. Okay? So drawing this out again, first off, if we're going to insert 3 arithmetic means, okay, just based on what we did with these, we're going to add D. We're going to add D. Can't see that. 4 times. If we want 3 numbers between to get from 10 up to 25, we're going to add 4 times like we did up here, right? So that means using our general formula here to span from 25 down to 10, we've got to span 15 numbers, and we're going to be adding 4. Oh, look, this is not going to come out evenly, isn't it? I told you they might not. They don't have to. Okay, so that's 15 over 4. That looks like, what is that? That's 4 and, oops, no it isn't. It's 3.75. If you divide 15 by 4, 15 divided by 4, yep, 3.75. So that means the common D is equal to 3.75, yeah? That's not very good handwriting, is it? 7, 5, like that. Okay, so writing out fair and square over here, that means 10. We've got to get 3 numbers that if we add 3.75 each time, will count up to 25. Well, okay, so what are the numbers? Well, 10 plus 3.75, that's going to be 13.75, right? And then 13.75 plus 13.75 again. If we add the D again, that's, oopsie, not 13. We're adding 3.75. We're going to 13.75. And that's 17.5, right? And then we add 3.75 again, and it takes us up to 21.25, right? And if we added 3.75 again, that takes us up to 25. So you see, each time we added 3.75 between each number, and it took us from 10 to 13.75, then to 17.5, then to 21.25, and then to 25. So these do not come out necessarily evenly, but this process here, where it's, and I'm going to write it out, let me see, purple. This process here where it's the final number, the ending number, the bigger number, minus the smaller number, divided by 1 more than the terms you want to add in there. So a general formula, I'm going to put it right here for add n arithmetic means between 2 numbers. Let's call them A and B, would look like this. The D would be equal to B the second one, the subsequent one, the one that's further in the sequence, minus A divided by n plus 1. And that gives you the what would have to be the common difference, and use that number to add from A up to B, counting up. Okay? All right, cool. So this is we're 20 minutes in here, so I'm going to stop this video right here. There will be some classwork for some of these to practice, and I will get on to the next video in which we'll do another kind of arithmetic sequence problem. Bye.